Hello dear students, this is Professor Feroza, and in this video I'll tell you how to use the MATLAB software for your DSP lab, that is the Digital Signal Processing lab. For that you have to use the MATLAB software. So you need to click on this icon, that is the MATLAB. Double click on this icon. So this MATLAB will get opened. It will take a few seconds. Now this is the MATLAB software. So here you are having initially two windows, that is the command window and the workspace window, and this is the current folder window. Okay, now here we want to write our program. To write a program we have to open a new file. So in MATLAB the file is known as, or it is termed as, script. Okay, so we will open a new script. We'll click on this new script. Now new script has been opened, and this window is called as the editor window, where we will be writing our programs. Fine. So now how many windows we have? We have three windows. One is the editor window for writing the programs. Another is the command window where we will be checking our output, and another is the workspace where you will be having the previously used commands. Okay, if you have written any commands previously for your programs, those all commands will be appearing here in the workspace, and you can directly take the commands from there if required in your program. No need to type directly, you have to click from copy and paste here, or you can click that and paste here. So that is nothing but the use of the workspace. Now always when you write or you start your program in MATLAB, first you have to write a command. You have to start with the command is the CLC, that is the clear the command window. Okay, CLC is nothing but the clear the command window. So this window, this command window, it will be cleared whenever you type the CLC, and here we can add a comment by typing the percentage sign. Okay, percentage sign. And what is this command for? This command is for clearing the command window. Okay, now next command which we are using is clear all. Clear all is nothing but the command which is used for clearing the workspace window. Okay, here this workspace window is, it is now empty now, because in the previously I have used the clear all command, so it is being cleared. That is, we don't have it will not display any commands which we have used previously. So clear all. Then next is the close all. Okay, next command is close all. Always you have to terminate a MATLAB command by using a semicolon. So close all, it will clear the windows previously used in the MATLAB, like histogram window will be there. Okay, so all the commands which all the windows which are being opened previously with respect to MATLAB will be closed. Now always you have to try to write these commands, these three commands, because it will be helpful. Otherwise some garbage value will be stored or retained in your used variables, okay, which will mislead your programs. So always you have to make a habit of writing these three commands at the starting of your program. Now I will show you how to write a program to display or to generate a sine wave and to display it using a plot function in 2 dimension. Okay, for that first we need to take the sampling frequency as Fs. Fs is equal to, I'll take it as 4 kilohertz, that is nothing but 4000, end it with a semicolon. Then I'll take the time period, Ts is equal to 1 divided by Fs, end it with a semicolon. Then I'll take the analog frequency, then I will define the time interval T, that is equal to 0 semicolon, I'll take it as 5. Okay, and end it with a semicolon. Now here what I have taken the time interval T is equal to 0 colon 5. It means it will start at 0, it will end with 5, and it will generate a series of values to variable T. That is, the first value will be 0 and it gives up to 5 by taking the default increment. So here the default increment will be +1. That is, your axis will be having 0, +1, +2, +3, +4, +5. That is, it is taking default increment as +1. Now suppose we don't want the default increment, we want to add increment of our own choice. That is, we want to add the increment in steps. So what you can do is you can define that in between the semicolons. That is, here one more semicolon you have to put, and in this semicolon you have to write the increment step. That is, here we will take it as TS, which we have defined here in the earlier command. Okay, now next is uh, here after this we will write the equation for the sine wave. That is, x is equal to sine open bracket 2 multiplication operator, that is 2 pi ft. Okay, 2 pi pi. Okay, here we have to write pi like this, then star, again that is nothing but the multiplication operator, x, not x, sorry, f. Okay, f, again multiplication operator, and t. Now close this. Okay, next what you have to do is we will plot it. Plot of t comma x, that is, we are plotting t with respect to x, then again terminate it with the semicolon. Now we want to label this graph. Okay, that is, we want to label the x-axis, we want to label the y-axis, and we want to give a title to the graph. So I will take x label command. X label command, it is to label the x-axis, then inverted comma. Here we are taking it as time, that is in seconds. Okay, again inverted comma, close the bracket, terminate it with a semicolon. Then we'll take y label. Y label, at y-axis we are taking amplitude. Okay, amplitude, inverted comma, close the bracket, semicolon. Now I want to give the title for this graph. So title, what this is for? This is for sine wave. So sine wave, then again inverted comma, close the bracket, semicolon. Fine. Now we need to save this. So save. Okay, what I'll give it as sine wave. Always you have to save the programs in MATLAB with the .m extension. Now save. Okay. Yes. You can create a folder and you can save your programs in that. So save. Now next, run. Run, change folder. So here there is an error in your line, that is, it is 2 pi, x is equal to sine 2 into pi into f t. Then we have plot t comma x. So I'll run it. So again you have a like a you are getting an error. So it is fs is equal to 4000, ts is equal to 1 upon fs. We have not defined f, no, so we are getting the error. So we'll take f is equal to, so f is equal to what? F is equal to analog frequency. So analog frequency I'll take it as 4, that is, I'll be taking it as 4 hertz. Now save it and run it. So this is your sine wave. Okay, see here, this is your sine wave. So it is starting from where? It is starting from 0. Always your sine wave will start from 0, and we have taken the interval as 0 to 5, and we have defined the intervals, that is steps are 0 is to 1 by fs, that is nothing but ts, then semicolon colon, and 5. Okay, so this is our what? This is our sine wave. Now next we will see how we will see to plot the cos wave. Okay, same steps you have to take, that is, from here we'll copy Control C and then Control V, but we want to plot for the for the cos wave. So we'll define cos wave by y is equal to, here we'll take it as cos 2 pi ft, then plot t comma y. Okay, then x label time in seconds, y label is amplitude, title is what? This is for cos wave, that is nothing but cosine wave. Now again we will save it and we will run it. Okay. Wait. So what I've taken, y is equal to cos 2 pi ft, then plot t comma y, x label, y label, then title. Correct it is. So now we got it as cosine wave. Now see, your cosine wave, it will start from 1. So it is a cosine wave. Sine wave was starting from 0. Cosine wave is starting from 1. Now we want to see here what we have done. First we have executed for sine wave, then we have executed for cosine wave. Both are getting executed, but for sine wave we are not getting the graph. We are getting the graph for cos wave because it is overwriting the sine wave. Now if we want both the waves in the same window, okay, what we have to do is first we need to change the color of our sine wave. That is what we will do. We will add here one more variable, that is nothing but color of the sine wave. That is, I'll take red color and I want dotted lines, so I will type, sorry, dash dash and inverted commas. Okay, now what I need to do is I will take another command which is called as hold on. Hold on means what it will do, it will hold the output of the sine wave and it will also plot the cos wave. Okay, so again we'll save it and we will run it. So when we run it, what we are getting, see, we're not getting y. So x label, so here this hold on must be before the plot. Okay, before the plot. Now we'll run and see, run, save and run. Now we got, see, so here this is our this dotted line is our sine wave. Okay, we have taken it as red color and dotted line. So here it is nothing but sine wave which is starting from 0, and blue is our it will take by default blue color, so it is starting from 1, that is nothing but our cos wave. Okay, then now next we want to plot our sine wave and cosine wave separately in the same figure window in different quadrants. So what we'll do is we'll use a function called as uh, subplot. Okay, so for that what we'll do is we will remove this hold on, and now we don't want this color. Okay, so here I will write subplot, then I will define the number of rows and number of columns. I want only two figures, so I will take two quadrants. I will take one row, then I will take two quadrants. So one row and two columns. So first is for row, that is m is equal to 1, that is for row, and n is equal to 2, that is for columns, and where we want to locate our figure in the first quadrant. Okay, then close and semicolon. Then next what we want to do, similarly for the cosine wave we have to do. So here again copy the same command, that is the subplot, control C, then control V, but here the position must be in the second quadrant. Okay, now save and run. See, So this is our sine wave, this is our cosine wave, both we are getting in one figure window. And here the sine wave, it is starting from 0, and the cosine wave, it is starting from 1. So this is how you can use the subplot, that is, it is one row and it is having two columns. Fine. Then now suppose I want to change the uh, axis values. Okay, x-axis and y-axis values. So what I will use is, see, initially here it is starting from, where it is starting, it is starting from 0 and ending at 5. Here it is 0 to 1. Now I want to change these values. So what I will do is, I will use a command called as axis. Okay, then round bracket, square bracket, x minimum, what minimum value you want. Okay, here I will change the value. I'll take it as 1. You can take any value. So I want my minimum value to be here, I want it as -2. That is nothing but the x minimum, and x maximum I want it as +2. Then you have y minimum. Y minimum also I want it as -2, and y maximum I want it as +2. And then square bracket. Okay, you want the square bracket, then close the bracket and terminate it. Now we'll save it and we'll run it. See, so this is a sine wave. hmm. Uh, hmm. The value for sine wave, it is not changed. The value for cos wave, it is changed, that is 0 to 2 and 0 to -2. Here also it is 0 to 2 and 0 to -2. We will type this here also and we will see what happens. Actually we have done it here only, no? So we'll control C, and after the title I will paste it here and I'll see what happens. So save, run. Now we got C. Okay, so for sine wave, x-axis 0, minimum value is -2, maximum value is +2. Y-axis, maximum value is +2, minimum value is -2. Similarly for cosine wave. So this is nothing but the generating of the sine wave and the cosine wave in the same figure window but in different quadrants. Okay, so this is the program for your generating the sine wave and the introduction. Fine.